Hello students, this is Mr. McAllen, and today we're going to be working on two types of problems. We're going to find equations of lines that are parallel or perpendicular to existing ones. And if I give you some data, I want you to be able to, through picking 2 points on the data or from the data, find equations of lines through those data points. So, first things first, let's just get a couple notes out of the way. You should know that if two lines are parallel, then their slopes are equal. And if two lines are perpendicular, then their slopes are opposite reciprocals. This is a skill or a fact that you may know from early on in math, probably Algebra 1, but it's something that will be necessary for doing the problems that we're going to do today. So in example 5, that we're going to have example 5 and 6 from our last lesson. We have a line that passes through a point, 1, -2, and is parallel with a line with the general form, the standard form of 2x plus 3y equals 1. So what we want to do is we first want to find the slope of our line, and we just want to solve for y. So we get it into slope-intercept form. So 2x plus 3y equals 1. I'm going to just have 3y equals -2x plus 1. I'm subtracting the 2x. Divide by 3. And now I have the equation in slope-intercept form, and I was really just doing this so I could get the slope value. The slope of the line and of the line that's parallel to it are identical, and it should be -2/3. So now I'm going to put this into point slope form. And point slope form is just y minus y1 equals the slope value times x minus the x1 value from the point. And so I'll just write it in. My y1 value is -2. So that makes my y minus y1 equal to y plus 2, because of the negative on the negative makes it positive. I have -2/3. This is x minus 1. Now if I want to put this in slope-intercept form, I would have to distribute the 2/3. So this would be okay if I asked for point slope form. If I asked for slope-intercept, you would have to do a little more work. You would have to add the 2 over, or subtract the 2 over. So that's -2. And then you have to combine these two numbers fraction-wise. So your final result would be, I'll just write it over here, y equals -2/3 x minus, because 2 is really 6/3. So when I add them together, I'd have -4/3. So this would be in slope-intercept form. The next problem is to find an equation of a line that goes through another point and is perpendicular to an equation in standard form. So what we're going to do here is we'll solve again for the slope. So we have 4x plus y equals 3. Then we have y equals -4x plus 3. Our slope is equal to -4. But remember now, perpendicular slope is the opposite reciprocal. So opposite means positive if the slope before was negative, and reciprocal means to switch the 4 to a 1/4. We write out in point slope form, just like we did before. And that's going to be y minus -3. It'll be y plus 3 equals, pardon me, 1/4 x minus 2. So I'm going to leave it like that, only because I don't want to take up all the time. But one of the things I'm going to ask you to do on the Google form is I'm going to ask you to change this. What is this equation in slope-intercept form? Okay, so that'll be one of the questions. The next thing is we have some data. Now this data, I took this from our textbook, Finney, Domenico, Waits, and Kennedy, so I'm giving them credit. But this is an example from the book where we have some data points. We have x values, and we have corresponding y values that represent, as the problem says, personal consumption for several years from 1990 through 2007. The dollar amounts are in trillions of dollars, so this represents like 9.7 trillion. And what they want us to do is they want us to write a linear equation using two specific points of data, the 1995 point and the 1990 point. And then they want us to estimate their expenditures for the year 2006. Okay, so that's part B. And then they want us to predict the expenditures from 2010. And then they want us to superimpose the linear equation on a scatter plot. So what we'll do is we'll do this tomorrow in class on Desmos. But so we're really just going to do A, B, and C. So what I want us first to do, or I'm going to pause the video, but I want you to do part A, where you find the linear equation. Well, actually, I'm going to do it now because this is the purpose of the video, is to instruct you. So let's just use these 2 points to find the slope. So m equals, remember it's the y value, so it's going to be 5.0 trillion minus $3.8 trillion divided by 1995 minus 1990. So my slope is equal to $1.2 trillion per 5 years. And I'll need a calculator to figure that out. So that's going to be 1.2 divided by 5, which will be $0.24 trillion per year. So slope equals $0.24 trillion per year. Okay, so let's come up with the equation. Y minus y1 equals m times x minus x1. Now remember, x is the years, and I'm not going to put 1990 in here. I want this to be in terms of year 0. So at year 0, the real year is 1990. And when we get out to year 2007, that will be year 17. I'm sorry, at year equal to 17, that will be 2007. Okay, so here we go. So y minus the y1 value, I'm going to use this set of points, 5 equals the slope, which is 0.24 times x minus, now remember the x-axis has been converted to years since 1990, so this will be 1995, x will be x minus 5. And that's coincidental that that's 5 and that's 5, but that's basically because x is the years and time is, or y is the dollar amount. So we have our equation, y equals 0.24 x minus 5. And I'm going to add the 5 from the other side, so I get in slope-intercept form. I've got to distribute the 0.24 through to both of these, so I'll do that with a calculator. 0.24 times 5 equals 1.2. So this will be 1.2 plus 5, and then my slope-intercept form will be 0.24x plus 3.8. This will be my equation in slope-intercept form. Part B. Use the equation, estimate expenditures in 2006. So 2006 means that the year is equal to 6. Oh, not 6. I'm sorry. That would be 16. If it was 1996, it would be 6. So all we have to do is plug in to 0.24, 16, and we'll find out in trillions of dollars how much was spent. So go back to the calculator, 0.24 times 16 plus 3.8. And that will be 7.64. So y equals 7.64. Now, for homework, I'll ask you to submit your answer to Part C to predict the expenditures for 2010. So what is the year value going to be? And what is the expenditure amount going to be? Hopefully you have you understand what we've been doing so far with this this lesson, and tomorrow we'll practice more of this in class. But just answer these questions for the form, and we'll go over that in the beginning of class tomorrow. Have a good night.